Okay, good evening everybody and welcome to the third week instructor interaction for the Blockchain Foundation program. This is the cohort 2, week 3 instructor interaction. Last week we discussed about the consensus mechanisms and now we are moving on to the next section about programmable blockchains. So this week we will be learning about Ethereum blockchain, how Ethereum is a programmable blockchain, how is it different from Bitcoin. Ethereum enables banking for everyone. It is enabling a platform where anyone can join in, and it is acting similar to a Bitcoin kind of network where you can transact in the form of Ether as the currency. It is also a form of an anonymous internet because the KYC details need not be published on the Ethereum blockchain. The only detail that is available regarding the sender of an Ethereum transaction is the sender address, which is publicly available. So it is an anonymous form of internet in that sense. It is also a peer-to-peer network. There is no single centralized entity controlling the entire network. The network is acting or communicating in a peer-to-peer fashion, like a torrent kind of network. It is censorship resistant because there is no one that is able to censor or remove or act like a centralized authority in this platform, because every node in that network has equal privileges and it is working with the collective decision making of the entire network. It has some commercial guarantees, like there is a reward mechanism in place similar to that of Bitcoin, and also it can be used to build other decentralized application on top of it. That is the programmability part. So it is a platform which is enabling programmable blockchains. That means Ethereum, on top of Ethereum blockchain, you can contracts and deploy those smart contract as transactions on top of blockchain, and this will help the cost to improve. So it is also being used in decentralized finance applications and other such kind of derivatives. It is also having a collaborative development community. That means any governance rules that are enforced on the Ethereum blockchain, it is first the decision on that governance rules are first taken by the developer, the consensus or a decision making that is happening at a community level, and then that decision is then applied onto the chain. So this form of governance is chain governance. So Ethereum is the first kind of blockchain which introduced the concept of programmable money or this is the introduction to Ethereum. Now let us discuss about the vision of Ethereum. So the vision of Ethereum is to become one computer for the entire world. So that is known as the Ethereum world computer. So the Ethereum envisions to become like a programmable single computer that is having all the different decentralized applications running on top of it. So Ethereum different decentralized applications that are available, and to make sure that all the other any decentralized applications can be deployed onto it, and it can functions in a decentralized manner. For this purpose, it has achieved known as solidity, and there are other ways in which we can interact with that program, with the Ethereum world computer, by means of other programming languages like Viper also. So this is the concept of Ethereum world computer, where it is not confined to one single location, but a single ledger where which will form the base layer for other blockchains to be deployed on top of that layer. So that is the concept of Ethereum world computer. So you can read more about this in we have given an sufficient details regarding Ethereum world computer. Now moving on to the permissioned aspect of blockchain. What is hyperledger? So till now we were discussing about Ethereum and Bitcoin, so the idea of public blockchain is that to decentralize everything, the centralized system. But permissioned blockchains like Hyperledger, distributed ledger technology that is focused on developing frameworks for consortiums, and they can collaborate or form a synchronization among the peers in a private or a consortium environment. So in philosophy, the permissioned blockchains are restricted to enterprise grade deployment, and they have a governing body that is taking decisions regarding development aspects. They have various ledgers inside Hyperledger and various tools and libraries also. So the fundamental difference between this public and permission blockchain is that public blockchains are focusing on decentralization aspect. So while we increase the decentralization, there might be a reduction in transaction throughput, or scalability will be reduced. While Hyperledger based focused blockchains or distributed ledgers, they are developed for keeping in mind enterprise grade applications. They are developed for more number of transactions per second, because they are not focused on decentralization. So they are focusing more on the scalability and security aspects rather than decentralization. So that is the fundamental difference between public and permission blockchains. Now moving on to the Hyperledger projects, there are different kinds of Hyperledger projects in existence. There are distributed ledgers, there are libraries, tools, and there are domain specific applications. So the most famous distributed ledger in Hyperledger ecosystem is known as Hyperledger Fabric. So it is one enterprise grade DLT technology with privacy support. It was developed by IBM, and later IBM contributed it back to the Hyperledger ecosystem, and now that chain is being developed by and maintained by Hyperledger, and that Hyperledger is steered, or there is a technical steering committee. There are members present in that technical steering committee who make the decisions regarding the development phases of these distributed ledgers. So there are different other distributed ledgers also, like Sawtooth and Iroha, Indi, Burrow, Besu. These are all other kinds of distributed ledgers in the Hyperledger ecosystem. So the idea of Hyperledger is that all these distributed ledgers will go through a development phase, and once that cycle is complete, the remaining features or the best features will survive that cycle, and there will be one single ledger that will be maintained, and that will be the best blockchain in that ecosystem. So this is how Hyperledger aims to become a distributed ledger technology. It is constantly under development. Also, you can also see there are other libraries like Aries, Quilt, Transact, etc. And there are tools also, like Explorer is used to see the blocks inside the blockchain. And there are other tools like Hyperledger Grid is for supply chain applications. So this is a brief introduction to the Hyperledger tools and projects. So in the second part of this third week, you can read more about Hyperledger projects. Also, there is another kind of distributed ledger technology known as Corda. Corda is for enterprise banking applications. It is for consortium of banks, and that Corda application is specific to banking. So Corda is for a distributed ledger technology that is useful for banking applications. Moving on to discussion board queries. This time I happened to see a bit of interesting queries from your side on the discussion board. So let us discuss the queries that you posted on the discussion board. Next. So the first question that I came across was, how can we manage to overcome Bitcoin limitation after a point of time? So talking about the Bitcoin limitation, the most important Bitcoin limitation is that it is having a lot of energy consumption. So there's a lot of controversy regarding that topic. like Bitcoin consumes more energy than some countries, but the Bitcoin proponents say that is baseless. But still, there is the issue that proof of work algorithm, it consumes a lot of electricity. But to answer this question, that is, if that is considered as a limitation of Bitcoin, then for that there are other blockchains in existence that are coming up, like Ethereum or Cardano or Polkadot. So these kinds of blockchains, they are moving towards another other kinds of consensus mechanisms, such as proof of stake kind of mechanisms, which does not require this hardware based consensus. That doesn't, I mean, that does not require high electricity cost due to this functioning of application specific integrated circuits. So in that sense, new environmentally friendlier blockchains are coming up, like Ethereum is moving towards proof of stake. There are new blockchains that are adopting proof of stake algorithm and other kinds of consensus mechanism, which does not require this costly electricity consumption. Next, we are going to discuss the next question. What is the necessity of gas fees in a blockchain, or for what purpose the gas fees is used? So gas fees is a term that is used to denote the transaction fees in Ethereum blockchain. So the necessity of gas fees in Ethereum, the gas fees is used to make sure that there is no denial of service attack. How can there be a denial of service attack? This DDoS attack can be done if there is no gas fees, because an attacker can simply keep on sending zero ether transactions to the network without incurring any cost. So if there is no gas fees, there is no cost. So an attacker can simply flood the network with zero ether transactions. So in that way, the network can be taken down by a denial of service attack. So for that, there is a necessity of gas fees. Also to incentivize the network, for example, if you are going to deploy a smart contract in Ethereum blockchain onto the Ethereum blockchain, then you need to pay for each and every command or each and every low level command in that particular smart contract. For each execution of that command, there is a gas fees associated with it. So that is a way of incentivizing the network to make sure that each and every node in that network is incentivized in some way, so that this gas fees will be used as a token or as a fees for performing that particular operation for that network. So this gas fees is an incentivization mechanism used in Ethereum for that purpose. And ether is a cryptocurrency or the currency that is used to fuel the Ethereum blockchain. So I hope I answered those two questions. Now moving on to the next question. What is the role of a blockchain developer in Bitcoin, Ethereum, Hyperledger, etc.? So a blockchain developer, he can be defined as someone who is developing a blockchain. So in that sense, if he is building a blockchain from a scratch, then that particular person's role is to maintain or write the source code of a particular blockchain from scratch, then program the blockchain using some language, like Bitcoin was coded using C++. So using that particular programming language, they will code that particular blockchain. They will develop that source code, and they will implement the consensus mechanism. They will give the network privileges, create the network, and deploy the network, and test the network. So that is the role of a blockchain developer who develops the blockchain from scratch. The other kind of blockchain developers that we see most commonly are the smart contract blockchain developers. So their job is to create smart contracts. These are legal digital contracts that are enforced by the blockchain. They are written in Ethereum. They are written in languages like Solidity or Viper. Solidity is similar to JavaScript, and Viper is similar to Python. So using these languages, the blockchain smart contract developers, they write smart contract code, and they make sure that, and they test that code and make sure that it's error free and it's conforming to all the rules. And once it is tested and vetted properly, then it is deployed onto the network. So in Bitcoin, the role of the blockchain developers will be to uh, maybe create a newer version of the blockchain, like while in the time of hard forking or soft, or in the time of uh, changing the block limit size, the size of the block, or such kind of changes to the protocol. For that, we need blockchain developers in Bitcoin. So that is there's a Bitcoin community who is developing the particular or maintaining the particular Bitcoin blockchain. So they will those developers, those blockchain developers, or those Bitcoin developers will maintain that network. They will come to a decision whether to increase the block size in Bitcoin. Just to give an example, whether to increase the size of a block in Bitcoin or not. They will first take a vote, and if majority agrees to take to increase the size, then they will approve it and they will go on towards increasing the size using the blockchain developers. They will change the protocol in a hard fork. So that is the role of a blockchain developer in Bitcoin. In Ethereum, I mentioned, in Ethereum and Hyperledger, as I mentioned, the smart contract developers, they develop code, they set rules, and they create decentralized applications on top of blockchain. So the blockchain developer is also expected to create the front end. So the blockchain is a backend technology. The smart contract rules are enforced on the backend. So the blockchain developer is also expected to create the interface and the front end for that particular backend also. So that part also will be taken care by the blockchain developer. So that is the role of the blockchain developer in Bitcoin, Ethereum, Hyperledger, and so on. Now, the next question is, can you explain the concept of UTXO, or unspent transaction output model? The UTXO model is the transaction model that is used in Bitcoin blockchain. Ethereum uses an account-based model. Bitcoin uses a UTXO model. So a simple way to explain UTXO model is imagining a paper currency, like the physical rupee that you have in your wallet. So simple application will be like you going to a shop and buying vegetables for 100 rupees. But when you check your wallet, the physical wallet, you will see that you have only a 500 rupee note. So the unspent transaction output is similar to that. Now you will give the 500 rupee note to the shopkeeper, and what will happen? There is a input generated, the 500 rupee note, and there is an output. The output is the shopkeeper will keep the 100 rupees with himself, but he will need to give back the change, 400 rupees back to yourself. So that shopkeeper will give back the 400 rupees back to yourself, and he will keep the 100 rupees with himself. So this kind of transactions are which generate an input. There will be an input like a 500 rupee note, and outputs are generated by that transaction, that is the 100 rupee note and the 400 rupee note. There is no 400 rupee note, just assume there is a 400 rupee note. So this is how a unspent transaction output works. That is, there will be an input and there will be an output. So in order for you to spend some money using UTXO model, you need to take the inputs that you received from somewhere. You need to show that you received some inputs and you have that sufficient money, and using that inputs you can do the transaction. You need the inputs to conduct some transaction, and after you give some inputs you will get outputs. In case of the example I mentioned, there is an output of $100 giving to the shopkeeper, and a change that is coming back to you of a 400 rupees. Okay, so that is how the UTXO model works in simple language. Okay, to understand more about UTXO, you can join the Certified Blockchain Associate program or audit the course. In that, it's explained properly. Now, what percentage of messages is expected to be received in PBFT? Okay, so I think this question is regarding the PBFT concept of how much percentage of messages is expected to be received. So this is related to the Byzantine fault tolerance example, where we mentioned that there will be a lot of I mean, there can be message lost when that messenger passes through the enemy city kind of scenario. So in case of PBFT, there is one of the condition is that there should be fully connected network. So full peering is assumed in a PBFT network. Full peering means if there are 10 nodes in the network, every node is connected to every other node. Okay. So in that case, when every node is connected to every other node, we should expect that most of the messages, or maybe we cannot put a number, we have to expect that majority of the messages will be received by all the participants in the network, since it is connected in a peer-to-peer manner and there is full peering in a PBFT network. All the participants are known to each other, and it depends on the communication protocol used. Suppose you are using a TCP protocol, there can be more percentage of messages being received, or there can be less if it is using a UDP protocol. So we cannot explain regarding the percentage of messages what kind of protocol is being used. So just to give an example, I mentioned TCP and UDP. It is nowhere related to blockchain. Then can anyone from the node trace a transaction in blockchain? The answer, in public blockchains, anyone from the node or any node, they can trace the transaction in a blockchain. So anyone who is a participant of the network. So what is a node? A node is a computer or a system that is existing on the network. So any person who is who has access to that node, they can obviously trace the transaction in the blockchain. In a public blockchain, it is possible. So in public blockchains, all the transactions are known to each other. So there is no restrictions. Anyone can participate in the network and anyone can trace the transaction in public blockchains. But in permission blockchains, there can be restrictions. Suppose in a Corda, let me take an example of Corda. There can be a bank A and bank B and bank C. There are 3 banks. So if the bank A transaction transacts with bank B, and it is a private transaction, so that is possible in a permissioned in a Corda kind of distributed ledger. So that transaction will be visible to only bank A and bank B. Bank C will not be able to trace a transaction between bank A and bank B. So that there are private channels kind of networks that are available, like the Corda network, which facilitates that in the privacy aspect is preserved in such kind of transaction, in such kind of distributed ledgers. So to answer your question, in public blockchains, every time a node can trace the origin of any transaction, it is possible. But in permission blockchains, there can be restrictions on the accessibility of private transactions. Okay. So I hope I answered that questions. I'm trying to answer to the best of my abilities. Next question is, what is meant by forged or minted in consensus? So there is a ancient history where the word soldiers was derived from the word solidus, which means gold. So the soldiers, they were paid in gold in the ancient times. So from that word, their name became solidus. Okay, solidus was the Latin word for soldiers. So from that word, it came to be known as soldiers. So forged or minted means the history of currency. You might remember that first came the barter system, then came the coin, and now the paper currency, then came the cryptocurrency. So the coin system, it was forged, means forged into round shapes so that it is easier to carry, and minted means minted into a particular shape or something like that. So forged and minted means it is related to the history of currency. So that terminology was adopted into the blockchain world. So forging or minting means creating a new currency. So forgers or minters are those who create new currency. So what is meant by forged or minted means they created some kind, they are validators who created new currency out of nothing, or they are creating from the network or something like that. So that is the meaning of the word forged or minted in consensus. What is 2f plus 1 in PBFT messages? So 2f plus 1 in PBFT, it is related to the working of the PBFT algorithm. So f represents the number of faulty nodes in the system. The total number of faulty nodes in the system is represented by f. So 2f plus 1 means how many number of messages are required by the working nodes in the system to function in a proper manner. So 2f plus 1, if there is one fault, then 2f plus 1 means 2 into 1 plus 1 equal to 3. So that requires at least 3 messages in that network should be received by the working nodes to approve a particular transaction or approve a particular block in that network. So for the transaction approval or the block approval purpose, it is done by means of the consensus is achieved by means of this 2f plus 1 condition. So 2f plus 1 is a criteria that is set by the PBFT algorithm to make sure that there are sufficient number of messages. So minimum number of messages that are required for a particular consensus mechanism to occur is known as 2f plus 1. So f is the number of faulty nodes in the system, and there should be minimum 2f plus 1 confirming messages that are sent by the other working nodes to approve the particular block of transactions. So that is known as 2f plus 1 in PBFT. So which are the other interesting aspects of blockchain technology? So I think the question is regarding, other than cryptocurrencies, what are the other interesting aspects of blockchain technology? So blockchain can be used as a distributed ledger, as a shared ledger, or as an immutable ledger for for trusting the system. So like can be used in many government use cases for making sure there is transparency in governance. That is one example. Another example, it can be used in banking solutions, where it can be used as a trusted ledger or as a channel between different transactions to maintain that synchronization between the different participants in a banking system. Just to give an example, suppose you are going to open multiple bank accounts. So every time you go to a bank, you need to fill the KYC form every time. So if you open 10 bank accounts, then you have to fill the KYC form 10 times. What if that KYC, there's a consortium of banks and that there's a shared ledger. So if you are going to open one bank, then you give your KYC. Then next time you go to another bank, that bank can take the KYC from the already existing shared ledger. Then that will enable a smoother process, right? So that is just one example, just a raw example of how blockchain ledger, shared ledger can be used. So there are other interesting aspects as well. Like right now there are many use cases coming in from in blockchain in ethereum ecosystem, like non-fungible tokens are one example. So the artwork, digital art forms, they are sold as NFTs these days. So that is one interesting aspects of blockchain technology. Another aspect is the blockchain in gaming. We can gamify tokenize the game characters, or we can gamify the characters in gaming. So there are various other interesting aspects of blockchain. So also enterprises are trying to adopt the distributed ledger characteristics of blockchain into their ecosystem, so that they can form a trusted transparent chain across the different stakeholders in an enterprise system. So people are trying to figure out the ways in which blockchain technologies are used in different application areas. Another interesting question is, for proof of stake algorithm, if only one node is having high stake in the coin base is chosen for block generation, then the node having high stakes will continue to have high stake, and node having low stake will keep having low stake because the algorithm itself encourages that. What now with this? So this is a very interesting question, because the proof of stake algorithm in its theoretical form, it states that the higher the stake, the more chance of you becoming a leader. But in actuality, what is happening is that the stake is one aspect. You will get more probability of becoming the leader when you are having a higher stake. But uh, there is a lottery mechanism that is enforced among the different validator nodes who have staked some cryptocurrency coins. So there is a luck element also involved in proof of stake. So that is one point. Second point is that you might have heard about the beacon chain implementation in Ethereum, that is known as Ethereum 2.0 beacon chain. In that implementation, there's a limit of 32 ether that can be staked. So anyone can only stake, any node can only stake maximum of 32 ether. So there's no question of high stake or low stake. There's 32 ether stake, and all the validators are randomly selected using a lottery mechanism. One of the validators is selected from those who staked in 32 ethers, from those who staked the 32 ethers. So in that sense, Ethereum solved this issue by capping the number of ether to be staked. So there is no, everyone will who want to become a validator, they will have to stake 32 ether. So that is, I hope I answered your question about staking and having a high stake or low stake and so on. So the last question is, please enlighten us on the research opportunities in this field of blockchain technology, crypto coin transactions, etc. There are a lot of research ongoing into the scalability aspects of blockchain. So Matic network is one example. The previously known as Matic, now it's known as Polygon. It was created by Indian entrepreneurs from IIT Bombay. So they developed this Matic or the Polygon network to increase or improve the scalability of Ethereum blockchain, to increase the number of transactions by providing side chains in Ethereum. They aim to become an internet of blockchain kind of ecosystem, the Polygon or Matic network. So that is one research opportunity, how to increase the scalability in blockchain. Right now, the transaction per second in the base blockchain like Bitcoin or Ethereum are very low when compared to Visa or other kind of centralized networks. So how can we increase the scalability without affecting decentralization or security is the major research that is going on currently in the field of blockchain technology. Another area of research is on, like you mentioned, like the cryptocurrency aspects of like how we can use cryptocurrencies in decentralizing the current financial system, like derivative trading or maybe some insurance or borrowing and lending, yield farming. There are various aspects of decentralized finance. There are a lot of research going on into how decentralizing the financial system can enable growth in the economy. So that is another aspect of research opportunities, how to use the coin aspects or the DeFi aspects, how to research on, improve on the current systems and make it more decentralized. And another research opportunity is in the field of distributed ledgers, how the various distributed ledgers can be created, how they are trying to build new kinds of distributed ledgers so that these distributed ledgers will enable faster transaction and more synchronization among the participants. And one personal research interest for me is in the consensus mechanisms, how the consensus mechanism or the algorithms can be improved so that there can be faster consensus mechanisms without obviously compromising the security, decentralization, or the scalability aspects. So these are some of the research opportunities in the field of blockchain technology. Now, that's all that I wanted to share with you today. So thank you for asking all the questions. I hope I was able to provide some feedback regarding what you asked. In the next class, you will be having the final quiz, and I hope you will be um, prepared and you will finish your course, and all the best. So thank you for now. Have a good day.